So we're going to discuss a little bit about relative formula mass. Now, there's something called the law of conservation of mass, and what that says is that the total mass of reactants will always equal the total mass of the products. And the law of conservation of mass says that atoms cannot be created or destroyed in a chemical reaction. And that's where this idea of the mass of the reactants must equal the mass of the products in any reaction. Now, just to recap that, what is the name given to the law that the total mass of reactants in a chemical reaction must equal the total mass of the products? Now remember, that's the law of conservation of mass. And the chemical equation with 28 grams of reactants is completed in a closed system, and that just means that all reactants are used up and no products escape. Now the mass of the products will always be equal to the mass of the reactants. So if we've got 28 grams of reactants, we'll have 28 grams of product. Now, relative formula mass, sometimes known as relative molecular mass, is equal to the sum of all of the relative atomic masses for the atoms in a formula. So it's easiest if we look at an example for that. Just to recap that, the relative formula mass is another name for the relative molecular mass. The relative formula mass of a compound is equal to the sum of the relative atomic masses of all the atoms in the compound. The relative atomic mass of an atom is the average mass of the atom. So just to have a look at that in a bit more detail, you can calculate the relative formula mass of a compound, but we need to do that. In order to do that, we need to know the relative atomic mass of the elements that make up that compound. Now, if we multiply the relative atomic mass by the number of atoms that of the element in that compound, we can then add these numbers together. So it sounds quite complicated, but it's really not in reality. So for example, hydrochloric acid, chemical formula is HCl, hydrogen and chlorine. Now the relative atomic mass of hydrogen is 1, and the relative atomic mass of chlorine is 35.5. So the relative formula mass, we'd add those two together, 1 hydrogen and 1 chlorine, so 1 for the relative atomic mass of hydrogen and 35 for the relative atomic mass of chlorine. So 1 plus 35.5 is 36.5. So we can say the relative formula mass of hydrochloric acid is 36.5. Another slightly more complicated example. So if we've got sulfuric acid, chemical formula for that is H2SO4, and the relative atomic mass of hydrogen is 1, the relative atomic mass of sulfur is 32, and the relative atomic mass of oxygen is 16. So if we've got H2SO4, we need 2 hydrogens, so that's 2 times 1, and we've got 1 sulfur, so that's 32, and we've got 4 oxygens, so that's 4 times 16. So you add together 1 times 2, 32, and 4 times 16. It will give you a total relative formula mass for sulfuric acid of 98. So remember, the relative formula mass is the sum of the relative atomic masses of the atoms in a compound. So when calculating the relative formula mass of a compound, you must first identify the relative atomic mass of each atom or element in the compound. The law of conservation of mass is the total mass of the reactants. It says the total mass of the reactants equals the total mass of the products. The relative atomic mass is the average mass of an atom. And in terms of relative atomic mass, if we think about the order we need to do to work that out for the relative formula mass, we first of all identify the relative atomic masses of each element in a compound. We then multiply the relative atomic masses by the number of atoms in that element, and we add up the results for each element to give us that relative formula mass. Now, can you remember the other name for relative formula mass of a compound? Well, that is the relative molecular mass.